project goals and come together and work on it. I like it.
Right, yeah.
Yeah, it's really nice. It's kind of quiet. It's kind of focused.
It's quiet. It's very quiet, and you don't have to. The only time it goes is if we beat people that day. But we have this.
Yeah, let's go. If you look there, let's show you some. Your goal from 10 to 12. We'll make those a lot. And we'll make the point it's actually like productive. You want to do something like that. So.
Actually, anytime.
That's fine.
Between 12 and 3.
Okay. Like I said, for any future project, we'll do.
Yeah. Anytime between 12 and 3.
Do you have a copy for yourself?
I've got a copy.
Alright, cool.
I came up with the basic outline, and then my partner just filled in my so now it's time to
Okay, so while I'm coming around and getting your proposals, a bunch of proposals out. That's one per pair, so not everyone's going to have them. Okay, let's take a look at this and just reflect on and observe what you. This was I graded this the last night or the night before. This was your the piecewise, the generalized piecewise assignment. So there were several people who had something similar to this. So I just want you to take a look at it and observe and reflect and maybe discuss what are your observations about this.
Yes. Find it a little bit.
It's okay.
Oh, no, wait. The one that's up there.
Okay. What do you notice? So it looks like, I'll just say, it looks like it's recreating one of the examples on the sheet. And it appears to be doing that accurately. What do you think?
It's really long.
It's really long. Yeah. So, and with each line, what happens? It's longer. What if we were doing 7 pieces? Okay?
For this one, this is the one that we could have just been, instead of like typing in that whole section again, couldn't we have just been typing in the F of
Okay, so Jocelyn's pointing out one of my hints to you in this assignment was that you can define piecewise functions recursively. Okay? And what does that mean? It means you can call upon the function within a line of the function, but there's one condition on that. So what requirement do we have on that? If we're going to call out, so if I'm going to end this line, rather than, I can call out the function f within this line, what is necessary for that map?
The function itself would have had to computed that value at a previous line.
Yeah, so it can't, whatever that function is, or whatever the value of the function, when it comes to here, it can't send it back to this line, right? That won't work. So you just got to make sure, if you use it recursively, it has to send it back to a previous or a different line in the code. Okay, so the hint was a hint about efficiency, right? This isn't efficient, but it's what many of you did. And it feels a little bit to me like it's working and it'll get the picture to show up right. but it should make you feel uncomfortable. It should make you feel uncomfortable when you type in this last line just from a mathematical efficiency standpoint. Okay? So I asked you to use the recursive. So some of you kind of just ignored it. So if I give you a hint or I give you guidance, it's because I'm trying to help you. So what I kind of feel like when I opened one of these, which there were several, is I feel like, oh, I just want to get this done, and I don't really know what he's talking about, but I can do it without it. But I'm trying to help you. Okay, so I'm trying to help you. Okay, so now here's another example. Fair enough. What can you do in that case? If you can't figure it out, what can you do? So observations on this one. Okay, we're using the function recursively. That's nice. What do we think? What do you see?
Well, just looking at it, it looks nicer.
Okay, yeah. So it's certainly more compact. And what will happen if we have 100 pieces in our? What will the 100 piece look like? It'll be the same thing, right? So no matter how many pieces we have, we know we have this nice compact form. That's nice. Okay. What else do you see?
Well,
Observations.
at breaking point 1, the function is discontinuous, and I believe the assignment was that f of x was continuous.
You're looking at the graph.
Yes.
Okay, so he's noticing something that's going on here. Somebody else, what's happening? Major issue here, James.
Well, like if you look at how the function is defined at breakpoint 2,
Okay.
says that first line, x is greater than equal to breakpoint 1 and less than equal to breakpoint 2.
Line 2, okay.
And then at the third line, it's also breakpoint 2 is defined again right there because there's another.
Okay, so what happens?
It's defined for both breaking points.
So if we put whatever breakpoint 2 is, when breakpoint 2 is in the function here 2, breakpoint 2 is the value 2, what happens when 2 goes into this function? I'm not even sure what it's going to do, but this is defined at both values. So what's happening here? You see it?
It's not supposed to have less than equal to that.
It looks like it's just graphing the first section, and since the other section's coming up with an arrow.
What breakpoint is this?
Breakpoint 1.
That's breakpoint 1, right? So that's at 9, x equals 9. So do we have the same issue there?
Yeah.
So why does it look like this? Yeah, Michael.
I mean, it's just because x isn't going to be greater than 9 and less than 2.
So breakpoint 1 is an x value, right? It's an x value, it's x value 9 in this case. So what happens when 9 gets plugged into this function? Brianna, any other ideas? Eric? What does the function tell, what are we telling GC to do with the value x equals 9? Crystal?
Well, you don't really know because it's breakpoint, the point 9 could be in the first line or the second line.
Okay, so in the first line, what do we get? We get R1 times 9. What's the output?
-9.
Negative 9. What about the second line? So BP, we know BP1 is, that's our -9 that we just computed.
I think the issue is actually that your breakpoint 2 is equal to 2.
Okay.
Because you can never have a value for the second line that's less than 2 but greater than 9.
That's a good point. Okay. Yeah, so notice breakpoint 2. What are these breakpoints? What do they mean? They're x values. So what really, to make this make sense,
These features are
the breakpoints need to increase, right? The breakpoints need to increase. So because that one's less, breakpoint 2 is less than.
We can't meet that.
Yeah. But it's basically we're violating the idea of a function, which is what?
Every x, 1, 1.
Yeah, so when you plug in, it has to be determined. Outputs have to be determined by what input you put in. It's like we're giving it 2 outputs for the same input. Okay? And so this also creates the difficulty of kind of this recursive thing where we're putting in breakpoint 1, but it's defined here. Okay, so how would we fix this to make it right? How would we fix this? Yeah.
We want to change the breakpoints, and then instead of having it be less than or equal to, it needs to be less than.
So all of them less than?
No, just the I'm trying to think about it. Before the x, the one on the left hand
Okay,
side.
when we call breakpoint 1, we want it to go to which line? When we call on the function for breakpoint 1, we want it to go to the first line, right? So which of these do we need to change, the first or the second? We need to make the first one strictly less than, so it doesn't include the input breakpoint 1, and we want it to be included in the previous line. Okay, any comments or questions about this? Yeah?
Was I right in my assumption that this was supposed to be a continuous function?
Yes. This
Well,
is,
then,
yeah.
I would argue if it's a continuous function, it's okay to define it this way.
But the second line, if you say that BP is 9 and BP is 2, you're saying 9 is less. You're saying 9 is less than 2.
You're just talking about the function, defining the function. So if this was 9, 15, 20, let's do that. Just put it in. So
Because the y value should still remain the same. Because that's kind of the point of a continuous function.
okay.
Is that we can take a function chunk, and if we put them together, those two chunks have the same y value at that breaking point.
Okay, so he's arguing that if we put in breakpoint 1, if we get the same value in both these lines, then it's fine. We can make it equal to here and equal to there. What do you think about that argument?
Both fixed values give you the same y.
It's still bad form. I'm just saying, in context of the
Okay,
problem.
it works.
Right.
Right. But is it mathematically, in terms of what a function is about, is it good practice, in terms of the idea of a function?
No.
It's not, because it's trying to take that value and do 2 different things to it. And granted, we've set it up so that it does spit out the same value either way. But we want to strictly have it, when we call an FBP1, we want it to go to a different line. We don't want it to go to this line. Okay, so, go ahead.
I'm kind of curious if this would also work backwards, where, say, could you call a line, could you call the last line instead of the first? Would it work? it wouldn't produce the same output. I'm saying if you wanted it to like instead work, like instead of it going along positively, if you wanted it to go along negatively from the origin, could it work if you wrote it like that, or does it have to call a line that came before it, not after?
No, it can call a different. It can call a line that comes after. That's fine. Yeah, because it'll just look at that and say, what's my x value, and it'll find the line.
And just go.
It'll just find the line and go to that line that x value falls in the condition. Yeah, so it doesn't have to be previous. It's just this is very systematic. We're building x from left to right, and so x is kind of building top to bottom. So we're always referring to the one above. Okay, so the lesson is, if I give you hints or give you guidance, I'm trying to help you. I'm trying to make you better mathematicians and help you, achieve the best result. So don't ignore that. Don't ignore that. And if you're stuck, then contact me. Okay? Contact me, set up an appointment, send me emails. Let's talk over email. But let's discuss it. Okay? Any questions, comments? Okay. Let's see. So I want to give you a following up on the Falling Balls project. Where is it? Back here. Where is it? Here. So variation. Falling coins. All right. So penny, nickel, dime. Okay, so there's a penny, there's a nickel, there's a dime. I can change the starting height of these. Okay? Well, that's what happens. Okay, I'll do it again. So let's put like that. And part of the program is not to make my Microsoft Word icon jump up and down. That is going to happen all class long. So what do you notice? What is happening here? So let me change things around here. Okay, so here's I changed them up. Check it out. Here we go. Okay, what do you notice? What's happening? How are the coins falling? What's determining how they fall, when they fall? What's going on? Okay, when the highest coin so what's the highest coin? The dime right now. The dime's the highest. So when the dime passes the penny and then passes the nickel. What else? How do they fall? Yeah, Chrissy.
Whichever ball is the one that starts first hits the ground first. The
Okay.
one that starts second hits the ground second, and the one that starts last.
Okay. So always true? Nickel first. Do we have a fictitious coin?
No.
Michael?
No, seems like the last ball that drops always drops at a constant rate. The two are like actually
Okay, let's put them all pretty high, and that'll help us see whether or not that's true.
What if you had the
All right, so this will help us to verify that or not. Because I got the dime is the last one, but it's still pretty high, so we can see.
So the first one falling definitely triggers both of them.
Okay?
The second one falling doesn't trigger the third.
Okay, problems that this will present in creating this. Okay? What issues will you have? Yeah?
Can you do or statements in graphing calculator?
Um,
Like, could you do something where, like, this variable equals whichever is the highest, and use, like, or statements to figure out, like, if...
okay, so
this-
mathematically we can do that without or. So what can we use to do what she wants to do without or? Okay, piecewise?
Set nothing embedded ifs.
But say what you said again.
Where you could set what a variable is equal to being the highest, and doing it through, like, if h1 is the highest, if h2 is the highest, if h3
So there's a mathematical principle that she's highlighting there that graphing calculator has no problem doing. What is it she's talking about? She wants to know which coin is the... Yeah, so what in graphing calculator? Okay, so this is not on the books right now, but I just wanted to show you and have you think about it. But if you understand the Falling Balls project, then it's different, but it's not this much more difficult thing. Okay, and now that we're getting better at tending to the mathematics of it rather than just trying to make the visual happen. You give it the right mathematics, and the visualization just happens, right? The visualization just happens naturally. So that's the way we want to focus on this and other stuff coming up. Any questions about this? Okay, so I'll let you know more about that. And if you want to start working on it for fun, you are welcome to do that.
Is there a video up for it?
I can make a video. Yeah, I can make a video. Okay, so what we're going to work on today is so here is a triangle, and then there's two points here, and actually these are center points of rotation. Okay, so angle 1, if I change angle 1, it's going to rotate that triangle around that first point of rotation. Okay, angle 2, same triangle, rotates it around the other point. Okay, but here's the catch. If I rotated some angle using angle 1 about the first point, if I invoke angle 2 now, it's going to rotate it from where angle 1 left it off. Okay, so it doesn't rotate. It's not separate. It's not rotating the original triangle. Angle 2 will always rotate the triangle around its point from wherever we left off with angle 1. Okay, so yeah, what's the idea here?
That's an output. When you rotate one, that's an output. And
That's
that
right.
becomes the input for the
Nice.
next
Yeah. Yeah. So the output of the first rotation becomes then the input, the starting point for the second rotation.
Would that work if you did it the other way around?
This is only set up to do that. Are you saying in this program right here?
Yeah, like if you did the angle.
No. So if I do that and now rotate this one.
Yeah.
Oh, okay.
That looks cool.
Okay.
Yeah. So you want to set the rotation we want around the first point there, upper right, and then from there.
Do one then two.
There's that one. Okay. A little bit going on here.
But if you wanted that, you could set another graphing calculator and change the composite.
Yeah.
And it could, no, you can see it
I mean, there's So
on a different.
having that be the first angle and not the second angle really is the exact same thing. It's just it's really the same thing. Okay, so how would you get started trying to create something like this? What would your And so I'm not talking about specifics of this, but a general strategy for embarking on something like this. What might you do?
Try and, I don't know exactly what you're asking for, but just try and set up transformation matrices.
Okay, what were we gonna say?
I was thinking about, this is probably way more difficult than it needs to be, but how you can do from point to point, having the line created, and have that line on the circle that is that whole degree around, and have it follow through that pattern, is what I was thinking, but I think that's way more difficult than it needs to be.
Okay, so general strategy for working towards this goal.
Maybe that idea she had, and then you would polarize with the end, with the circle, so that as you move it, each point makes a circle, has a radius around that point, and then the end would move the angle while the radius stayed the same.
Yeah,
Maybe?
so okay. So again, stepping away from the mathematics of it. So you're all kind of talking about the mathematics of it.
Yeah.
And I'm saying a strategy for attacking the mathematics. Strategy for attacking the mathematics. Everybody have an idea? So this, for angle 1, this is the center of rotation for angle 1. Okay, and then this is the center of rotation for angle 2. But those can be moved. So those are, you know. So this is for any difficult problem. What is a strategy for making headway on a difficult problem? Okay. Special cases, break it apart. Very good. Yeah. Yeah.
Try and get one of the rotations to work and not the other.
Okay, that's the right idea. So it's like, can we do something really simple first? Like, is there like some kind of simple sub goal that we can do? So what would be a very, very simple sub goal to get started here with this. It's simple as you. What's that?
Just to move 1 point.
1 point. How?
In the rotation of the activity around that.
Okay. How about even simpler than that?
Set the center and a point.
So let's figure out how to rotate a point first. But even simpler than rotating 1 point around another point. Could be what? Just rotate a point around the origin, how about? First. Okay? So how could we do that as a function of, so how could we create a function of our starting point and the angle that if I change the angle will rotate that starting point around the origin that far of the angle. Okay, and then maybe as the next sub goal, so I think, so Jocelyn, is that you who said? Okay, so now, and if we could get that, then now we pick a center C and a starting point A. Same thing. Now can I rotate that point around the center? So the idea of small tasks, right? Small task sub-goals that will get us. So this is still a very far cry from what we need to do in the end, but it's, you know, getting the general idea and just making some kind of progress. All right. Okay, so let's figure out the mathematics behind rotating the point here. So here's our initial point, x1, y1. And the final point, we're going to rotate through an angle A, and we've got the final point x2, y2. So we can start by, and so this is some radius. Okay, so we can start by identifying the coordinates of these points in terms of the radius and the angle. So the angle for the first point, so the starting point, we'll call that angle B. Okay, so the coordinates, so we'll start with x1. How can we define x1 in terms of our angles and our radius? Alana. So what is x1 in terms of our angles A and or B and the radius? Not sure, okay. Alexis. Yeah, uh-huh. So x1, y1.
So it would be something about the angle times that, like r squared would be.
Okay.
Would give us like the vertical distance from.
All right, how about Brianna Korn? What would x1 be? Yeah, so that could be that scale could be saying anything.
You want the angle?
Eric, what do you think?
Cosine of something. I'm trying to think mathematically about it.
So what are we looking for here? We want x1, which would be this right here.
Yeah, it should be 5.
No, the scale could be anything, right? The scale can be anything. Okay, so Joel, you were raising your hand before.
times the cosine of b.
Okay, r times the cosine of b, right? Okay, and then y1?
R times the sine of b.
Well, that's easy, of course, now, right? And then, okay, so what about x2? What about x2? Missy? R sine of b? So x2, so I'm sorry, so this coordinate up here, x2.
And it would be r cosine of a plus b.
Okay, so Sarah's offering up r cosine a plus b. Missy, what do you think? You agree with that?
Yeah, because it's not equal.
Okay? Agree with that? Are we good? And what is our goal? We're trying to define what here? So kind of like, what is the end goal in this whole situation? What's that? Which point? So what's the result of this little sub-goal that we have? Jason? Is it an angle? Is it a radius? Is it a point? Ashley, what's our in the end? So what's the purpose of this little sub goal that we're?
Are we trying to get like an angle?
Okay, so is it an angle? Is that our goal? Crystal? Don't know. Well, so let's go back to what was the goal of this thing, this little sub goal that we had. We wanted to figure out how to do what? To get a point to move, right? So starting point, and then if we increase the angle, it would. Right. So what's the final? Yeah, Matt.
Is it just to get our first coordinate to move to our second one?
Right. So then the outcome is?
The angle that's needed to get there.
No, that's the input, right? That's the input. Yeah, the endpoint, right? The endpoint. This is our focus, right? We're just trying to figure out how to write a function that will give us that. Okay, so we're gonna. This is what we need to unpack here. This x2 and y2 coordinate, because that's our goal. All right, so we can use trig identity here. Some identity for cosine is. So we just look it up in the back of the book, right? Okay. Yep, and we get to add those.
Do we need to do that step?
Yes.
You could just add the slider value.
What's that?
You could just add, like, say, a to be a slider value, and just add that on inside of.
Yeah, so there's ways to do this, but we're working towards a matrix way of doing this, so that when things get with triangles and line segments and complicated things, it'll be really convenient to have a matrix form for this. Okay, so what is it in terms of? So we need to get x2 and y2 strictly in terms of what parameters? We've got it in terms of r, a, and b. Is it okay to have it in terms of all three of those? So what do we not want? What is this final point? We want it to be strictly dependent on what? The final point. So it's not all three, but it's two of them. Okay, it's two of them. So I didn't want to make you think it was just one. But so which two of these do we? Or is really? She's saying R and A. Agree with that? Yeah. So it's going to be R and A. So how can we get b out of this?
X2 minus X1, what's that do for it?
So notice we have, so r cosine A, cosine B. Anything we can do with that? R cosine A, cosine B.
Say R cosine B equal to X.
What else is it?
What's that, Joel?
Can you say R cosine B equal to X1?
Okay, so r cosine B. Is it okay to have x2 in terms of x1? It's a function of x1? So, this final point depends on r, it depends on a. Does it depend on the initial point? Sure. Yeah. So it's how far we rotate from that initial point. So we can do what? Cosine A times what? X1 cosine A minus r sine A sine B.
So
Y1 sine A. Is that right? Yeah, sine A. Okay, so that's x2. Similarly, y2. Can we do it without expanding first? What do we got? So here's r sine B. Y1 cosine A plus r cosine B. Yeah, get used to it. All right. X1 sine A. Okay, so that's our y2. So we got x2 equals x1 cosine A minus y1 sine A, and y2 equals y1 cosine A minus plus. Let me change the order of that. What did I do? I'm going to put x1 first. How do we do? Okay. So what we'd like, so our goal here is a matrix form. So given the point x1, y1, put it in a matrix. So this is called our rotation matrix. So what matrix do we need here that will, when multiplied by x1, y1, will give us x2, y2? Remember your matrix multiplication, how it works? So how does it work? It works, so you go across the row and down the column simultaneously multiplying and adding. So this times x1 plus this times y1 is x2. Then across the row, this times x1 plus this times y1 is y2. So, Mario, what's the matrix? You got the matrix?
Nope. You want it in terms of x2 and...
So it's, so whatever, so there's, this is a 2 by 2 matrix, and so when we multiply matrices, you go across the row of the first matrix, simultaneously going down the column, multiplying and adding. So this times x1 plus this times y1 is x2, and this times x1 plus this times 1 is y2. So we're using these equations then to kind of go backwards and get that matrix. Chrissy, cosine A,
Negative
negative sine
sine A.
A.
Not negative.
Okay,
Okay, what would be sine
sine A.
A and cosine A?
Does it work? Cosine A times x1 minus sine A times y1 is x2. Is that what that says? Exactly. Sine A times x1 plus cosine A times y1 is it y2? Okay, so we can define in graphing calculator. We can say, all right, let's do a function, and the function can be that can be a matrix, and that could be an angle. So this, what matrix would that be? If this is the input into our rotation function, which matrix would that represent? Brianna wants x1, y1. Agree with that? Yeah. So this would be our input matrix, right? And then A would be our parameter for angle, which would be this matrix. Okay, so we can define a function that, given an angle, given a coordinate pair, spits out x2, y2. So see if you can come up with so to get a matrix, a 2 by 2 matrix, you hold down Shift. As you're holding down Shift, you click on the Math menu, and that gives you an option for a 2 by 2 matrix. Okay, as you hold down Shift, get the Math menu. So your goal now is to write the code, this code right here. Can I erase all that I've written? It is videoing, yes. It is videoing, if that's a word. Okay, so here's the thing. So the starting point can be any point, and then we can use a slider for the angle, and it should rotate our point around the origin. Okay, see if you can make this file. See if you can do it. Utilizing, of course, utilizing the math that we just did. Okay, so I put up my version. So this is kind of what I was talking about. So this is the key element right here. Okay, this is the key element right here. I'm calling my function capital R. The inputs are x and a. Okay, so x. So x, this is going to multiply this matrix by x. Okay, and then a is going to be my angle. So that's just the local variables. So whenever I invoke the function r, graphing calculator is going to look for what's there, and it's going to put it there. It's going to look for what's there, and it's going to put it in these 4 places. Okay, so now I'm invoking the function. I'm invoking the function, and I'm telling it put a wherever x is, right? Put a wherever x is. And that's my starting point, 3, 2. So it's going to put capital A right there. And then it says put angle wherever A is. So it's going to find the angle here, and it's going to put it in all of those. It's going to crank out 2 vector, and so that will graph then a vertical vector. So let's make sure we really understand that. So do you understand why I set up the code the way I did? So questions? We really want to understand how functions work. We define this function, and then we're gonna use it. So this x is just a local variable as I define the function. So anytime I invoke r, I can put anything there. You know, anything legal, and it's gonna then take that thing, and it's gonna always put it here. What's that? So here I'm defining the function, here I'm invoking the function. So when I say a there, it's going to find a, and it's going to put it there, right? And then it's going to find whatever the current angle is, 2754, and it's going to put it in all four of those places, and it's going to follow the rule. And so what does it do? It spits out this point right there. Okay. Anybody have a question? Yeah, Chrissy. Yeah, sure. Okay. So I've never used subscripts. I'd have to play around with it and see if I could figure out what's going on there. So I would have to name it something different. You wouldn't necessarily have to. It could work with subscripts. I'm not sure. I could look at it with you, but I can't answer the question because I've never used them. Other questions? Yeah, Joel.
Having a different point instead of the
Right. That's the next step. That's the next deal here. Okay, so now I've got still calling the original point A and the C for center. Can we do this? Okay, so what's the heart of this? So what's the key thing to being able to achieve this goal? What's it going to be all about? Okay, so it has to do with a shift, but what's the central element of making this little animation work? Anybody? It's going to be the centerpiece of what's behind the curtain, right? What's that? Matrix, okay. That's part of it. What am I jumping up and down about? What's the centerpiece of all of this? What's that? What formula? The equation. What equation? The rule. You gotta fall in love with these things, you guys. You just don't, you're not in the mindset yet. What is it we're jumping up and down about? Anybody know what we've been talking about the last 3 class periods? You're not going to forget now. Functions. Okay, what is the centerpiece of this? Lots of functions? One function. Okay, we'll call it R again. How many inputs will it have? Okay, I've heard 2, I've heard 3, I've heard 1. How many inputs will the function have? What are the 3? If you think there's 3, what are they? Okay, 2 points. So I called that X, center point, and there you go. What will be over here when you define that? In general, just in general, what will be a rule that has what? Okay, 3 by 3 instead of 2 by 2. But so general, what will be, that will be consistent, what will it consist of? A rule of what? This, this, and this. It's going to be a rule that invokes that cranks on the different inputs. And what will the output of the rule be? So when we do the rule, it will give us, what will it give us? What kind of thing will it give us? What's that? A point. Which point? Yeah, exactly. The final point. So I've got it as purple. So this output of this function then will be the final point after the rotation. Question?
So that will work for one point, but we need the
Yeah, let's make sure we got it one thing at a time. One thing at a time. Okay, so let's just, we'll see you in a week, right? And in a week we have the analyzing my lesson logic, which is, that's not a long, difficult thing. So in addition to that, I want you to come up with this rule. Go over this rule so you can finish this little animation. Just rotating one point around a given point. That's right. Rotating any point around a given point. Just like this. Okay. Gotta get in a functions mindset, alright? That's my goal for you. Have a wonderful break.
If I tell
Hold on a sec.